Hi Ankit.
Hello. Hey, hi guys.
Ankit, in the course curriculum, I have just seen that there are some practice assignments are showing over there
Mm-hmm.
for last two, uh, basically for the last two sessions.
Mm-hmm.
But those are basically on completely on a machine learning and a deep learning, like
Okay.
creating a model and everything.
Mm-hmm.
And I think we haven't touch upon that part, like what is the models, hidden layers, how we are writing a code. We
Mm-hmm.
we have done only just the theoretical part of understanding the machine learning and deep learning
Okay.
gen AI.
Mm-hmm.
But when I see the overall 10 assignments, they are saying creating a model that from scratch, from the scratch itself.
Mm-hmm.
Like one of the assignment is identifying digit digital fingerprint.
Okay. Don't worry, I'll look into that. I
Yeah.
haven't seen those assignment yet though, so if it is like that, I'll take a look into that. Don't worry. Yeah. And like last week itself, on the Sunday session, due to lack of time, we could not finish it. But I had like some notebook prepared to learn or to view how the code, like on the code part of the neural network as well, how we are creating those layers, how we are configuring certain part of the neural network to make it work. If time permits, we'll take a look into that today. Okay?
Hi, Ankit. I'm Rajiv.
Yeah. Hey, Rajiv.
Yeah, hi. Actually, I just joined from today only
Mm-hmm.
uh, because last week somehow I
No
saw that
problem. Mm-hmm.
this curriculum is already started from 3rd of
Mm-hmm.
May. So I
Yeah.
missed that last week session.
Mm-hmm.
So I also try to get the pre-recording. Recording if there any session recorded or not. So, but I could not find it. So it would help to, what you have, uh, what I have been discussed in last session. So
Mm-hmm.
because going forward, it will help me to get it.
Yeah, I understand. Don't worry. Maybe okay. I'll take a note of this, and maybe you can raise a ticket on support or something. That should be helpful. But we do have the recordings of the session, and you should be able to find somewhere in your learning portal.
Maybe as I was not part of this first session, that's why
Mm-hmm.
it's recording
Yeah, yeah, I
there.
can understand.
Maybe.
Yeah. Samshir or Shravan, were you able to find those recordings? Can you help Rajiv around that?
Yes. Yes. Yes.
Great. So Rajiv, maybe you can take help from Samshi or Shravan. They should be able to guide you where you can find those lectures.
Okay.
Yeah. Or you still face some difficulty in accessing, maybe uh, you can raise a support ticket and you should be able to resolve this.
Okay.
Yeah,
Thank you.
cool.
Thank you. One more thing, like just request because the term I have maybe it may unfamiliar to me. So if you request so any word that you can, small briefly
Mm-hmm.
repeat. So
Yeah,
going
don't
forward.
worry. Yeah, we'll go with that. Maybe Shravan or Shamshir, any one of you, can you brief or we can discuss what we have discussed in our last lecture? We'll be iterating over that as well before we start today's session.
So last week we have discussed about terminologies basically we use in Gen AI. Apart from that, we have understood the transformers, how the transformers in the machine learning, and the core concept into that, which is the self attention, positional encoding, and encoder in decoder architecture. Which is comes in a research paper in 2017. The basically transformer architecture use the encoder and decoder. There are some of them which use on work only on decoder, like GPT is only work on the decoder. Bird is use only Bird use encoder and decoder only. So, and the types of LLM which we use, like open source and the closed source, and understand what are the key terms in the LLMs, like embedding, uh, tokens, tokenization, context window. What is a context window? And there are temperature we have discussed. There are a few more which we need to discuss. Is like rate limit, hallucinations, zero shot or few shot. What is a zero shot and a few shots in prompts, and popular frameworks which we have is LangChain and Llama Index. These we need to discuss, which we haven't discussed in the last session. These were the pending item from the last
Yeah.
item.
Yeah. Thank you, Shamshir. So as Shamshir has already briefed Rajiv that we have discussed the basic building of from machine learning, how we have evolved over the neural networks, how internals of the neural network works, what is a neuron, some basic terminologies around neural network, moving to the transformers, internals of transformer, decoder, encoder, positional encoding, those framework we have discussed. And I would really request you to go through those basics because that would be important for you to understand how that is being used in our further sessions or how the language model is working, right?
Yes,
And
that's why I was searching this recorder because
mhm.
the term you have used is totally
Yeah,
good.
so these would be the common terminologies. Also, some of the terminologies around language models we have discussed in our last session. Some of them were left. We'll be taking them, or we'll be starting with them today, and then we'll be taking up from start the today's session. Yeah. So if some of the terminologies might be overwhelming for you as of now, but once you go through the lecture, you should be comfortable. Don't worry about that. Yep. So hi everyone. How are you all feeling today? How was your day? How was your week? Maybe put in the chat. No response. Looks like the week wasn't that good, is it? Busy. I understand. No worries. Yeah, so I hope you guys have revised from the previous session. You must have explored some videos, some articles, some blogs over the internet, and you must have got better understanding from the concept where we started. The discussion we had, there were the starting point, and there over there you can build and you can go into depth of each and every single topic that we discussed last week, right? The agendas, like the agenda for today's session, would be the working of transformers, how you can use the transformers, right?
Hello,
Starting from the coding part. Hello.
Ankit.
Yeah.
Ankit, actually, I was working on some. I
Mm-hmm.
think today's topic was the hugging face, no?
Yeah.
So I was working on to using hugging face for hugging face APIs for
Okay.
chatbot application. But
Mm-hmm.
I'm not able to do it. I'm getting some error. Can you solve it, or there will be any other session where you can take this type of problems?
Okay, so first thing, we haven't been to Hugging Face yet. We will go on to Hugging Face, how to use the platform, how to access the model
Mhm.
today in today's session. I believe that should be like you should be able to resolve that access problem. And if you are still not able to, if the time permits, we can look into that. But for now, I will not commit if we will be able to resolve because it all depends on the time that we will be having, right?
Oh, okay. So when will be the doubt session classes?
Doubt session, I'll need to check with the management regarding that, but you should be able to get some session around doubt clearing, some hands-on, some but debugging and everything. But I need to check with management. for that.
Because
I'll
you had
note it
given some
down.
assignment as well now onto this,
Mm-hmm.
so I was so thinking like it is a Hugging Face, today's is a session for Hugging Face, so I will
Mm-hmm.
I will get to know what
Yes.
is the error I'm getting in my project.
Uh-huh. Yeah, I understand. Don't worry. I'll check with the team and I'll get
Because
back to you
there
on
should
this.
be any at least one session
Mm-hmm.
for like our projects, because at the time we are I was enrolling, then the people were saying of your team na, that you can bring
Mm-hmm.
your own projects also so that you can
Yes, yes,
discuss.
we'll come there. We'll come there. Just
So for
uh,
that, and for that I need some session, or means any one session, so that I
yes,
can
yes,
ask
we'll come.
everything into that.
Yes, yes, I'll note this down and I'll check with the team if when
Sure,
can we
sure.
start with that.
Will
Yeah,
be good. Okay. Okay.
yeah.
Thank you.
Okay. Yeah, no worries. Shall we get started? We are already around 13 minutes into the session.
Yeah, yeah, sure.
Yeah. Okay, great. Uh, Okay, so for today's session, the agenda would be working with transformers from Hugging Face. Some of you might be aware of what Hugging Face is. Some of you might be coming across this term for the first time, but don't worry, we'll go through that together. And while we are working with the transformers, we'll see some code part as well. I have prepared some like how you can use those transformers from Hugging Face, some basic code around that as well. Along with that, we will also discuss on the fine-tuning part of the large language model, some of the techniques, some of the quantization techniques that we use, and how do we evaluate the model once we have fine-tuned a particular model for our use case. When to fine tune, when not to fine tune. These are also some of the key concepts that we'll be discussing or we'll be touching upon. So once we are completed with today's session, you should be able to understand the working of transformers. You should be able to use it. So as Raki had issue, probably that should be resolved by end of the session today. And you guys can also start working on some of these problem statements by exploring the transformers and Hugging Face yourself as well. Okay, shall we get started? How you guys are feeling today? Put it in the chat. Maybe show some energy, and then we can get started. Yeah, great. So before we get into the transformers and Hugging Face, let's just quickly touch upon some of the concepts that we had left in our last session. There were a couple of terms uh, which we need to finish before we jump in here. Okay, so this is from our last class. Some of the terminologies we have already discussed, some of these concepts, and we were left with some of them like embedding, semantic search, right? Till where we have finished, guys? Anyone remember? Yes, no?
We finished on embeddings.
Okay, we finished on embedding. Oh my God. Okay. So we are done till here. Okay, so in that case, let me pull in a notebook where you can actually see how to convert your natural text into embedding, how you can do that. Because along with embeddings, we also see something called semantic search or the cosine similarity, right? I think we have discussed the cosine similarity, but let's discuss it again. So for embedding, so embedding is nothing but you are converting your natural language text to numbers, right? When I say numbers, this is going to be a list of some numbers which like 1.2 minus 0.5, 3.4, 4.6, and like this. There is going to be the length depending upon which model or which type of embeddings we are using. The list, this length can vary, but these are the numbers which a model understands. So embeddings are these list of numbers which will help model understand what you are trying to convey through the model, right? This whole process is called embedding, and this is called the actual embedding for the input statement or in the input that we are trying to make. For cosine similarity, let's say you have a vector. We call this a vector, right? So This vector can be of different length like 256, 152, 256, 152, sorry, 512. Not just 152, it can be 1536. This is for OpenAI. OpenAI vector would be of length 1536. There can be vector like 1024. This is from BGE, right? So these are different vectors when it comes to end. These vectors, these numbers, depending upon different model, can be really good, can be really bad, depending upon what model you are using, how good it is in capturing the essence of the word that you are trying to make, right? So let's say I have one vector, I have the same text. Let's say I have text, I love pizza. And you have one vector for this, let's say with OpenAI. Like its length would be 1536, right? And let's say then you have another vector which is of length, let's say 512, which is from BGE model. Let's say this, I think 15512 is of small. So BGE has different models altogether. So you can use different models to convert your text into embedding. We will be looking into it, how we are going to do that. But what cosine similarity is? Let's say you are putting this vector of 1536 in an n-dimensional shape, and if we put it in 2 dimension, let's say this was the vector that was coming up for your I love pizza, right? And there is another statement for you, which is what do you call? Give me another. Okay, give me any random statement. Like, the weather is lovely, right? Let's say these are two statements which are converted to embedding each of length 1536. And the length, when I say length of 156, I'm not referring to this length. I'm referring to the dimension this particular statement is represented in. Okay. And what cosine similarity is? Cosine similarity is the angular distance between these two vectors. How similar these two statements are in terms of their meaning depends upon how close they are in their vector space. And by closeness, I mean the angular distance between these two vectors. And this distance or this similarity is called cosine similarity. Right? So for any natural language sort of task, there are n number or there are different methods like Manhattan distance, dot product. These are different methods to find the distance between these two vectors, right? But which one of them suits best for our use case when it comes to natural language? So that's cosine similarity that we can use, right? Cosine similarity is one of the best when it comes to natural language similarity. Okay, so if I compare, let's say, you guys tell me, I have one vector, let's say this was from my OpenAI, and let's say this was from my BG, right? Is it okay if I can compare these two? What do you think? Is it okay if I compare these two vectors? One is of OpenAI and one is from BGE?
No, it's not okay.
No? Why do you think so?
For comparing between the embeddings should be the one model only. Like if we are using the OpenAI model, so it should be the OpenAI embeddings.
Hmm. So these number itself, these are not just any random numbers that are put in here, right? There is some logical reasoning behind putting these numbers for a given text, right? These numbers can vary for different embedding model. As we saw, the size of these vectors can vary, right? So there is some different logic for each model, right? And comparing two different logic in the same space is like doesn't make sense, right? So when you are comparing the two vectors, make sure they are of same model or same like same logic is behind when they were created, right? So for OpenAI, when you are comparing, it should be the OpenAI only, right? And let's say in 3 dimension space, when we say, or let's say in 2 dimension space, let's say this was for king, right? And let's say this was for queen. Do you think the vector for king and queen would be relatively closer, right? Because they are all like they both are from like some royal thing. They are like some leadership kind of role and everything, right? And let's say there is another vector for men. and let's say this is the difference. Let's say the difference is A, and this is the kingship or the royalship. The difference between these two vectors is something about royalship or the gender change, right? So if I subtract this gender shift from my king, do you think I'll be able to get another vector which is for woman? Right? Because there is some logical representation. It is not just randomly put numbers, right? So this is how uh, this embedding and the whole thing logic works upon, right? So if I subtract a particular logic from a given vector here, let's say this was a gender. So if I subtract gender from my king, and I get queen, right? So if similarly, if I subtract the vector or the difference of this difference that I have got from my main vector, I should be able to not exactly similar to or not exactly same to woman, but closer to woman as a vector in terms of, I'm talking in terms of like the embeddings, right? So this is how cosine similarity helps us in
Hello.
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 Yeah. Yes, Samsir. Want to say something? Okay.
No, Ankit, please continue.
Okay. Sure. Okay, so this is how the concept of embedding and cosine similarity helps us. Even in our further sessions, we will be seeing the use cases of cosine similarity. And when I say cosine similarity, this similarity only that we are referring to. So we will be having one document, one statement that we will be having, let's say a user query. And for that user query, we need to, let's say we have a database. And from this database, we need to pull some relevant information for this particular question. This question is converted to embedding. This embedding is then done like relative or similarity search from my DB, and we'll be pulling. We'll be discussing in this detail. But this is the whole concept behind embeddings and cosine similarity, right? Any doubts in here? Then we'll jump into some hands-on or some coding part of it. How does it look like when it comes to uh, vectors? If you have any doubts, please, this is the time. Okay, are you able to guys see this is a Colab notebook that I have prepared.
Yes.
Okay, so for embeddings, it is, as I mentioned, this is just the numerical representation of data. You can also call it a tensor that we have discussed last time, right? And it is like data represented in like numbers which can be understand, like which a model can understand, and it is very helpful when it comes to making sense of a text in terms of number. Different information can be stored in this particular number. How to convert these text into numbers is what we are going to see right now, right? So we have different models available out there in the market, which you can use for embedding. How good or how bad a model is depending upon your use case. Different models are good for different use cases. So depending upon your use case, you need to pick which model you can go with, right? But if it comes to open source or closed source, there are some of the model like so this is something is called sentence transformer. This is a library which helps you transform your text into embeddings, right? This is a open source library available, and these are some of the model like All-Mini. All-Mini is one of the I would say one of the best model out there in the market that we are even like in my organization we are using this model at some places, right? Wherever we need to come with some sort of similarity, we pick some of the models which can be for our use case, and All-Mini is one of the model that we picks in first place because the performance is good. It is open source, and we can leverage these models, right? You need not to pay for them. They are available open source and you can use them from Hugging Face. We'll discuss what Hugging Face is in a moment. So let's say, first of all, you load the sentence transformer model this way. You pass the model name, which model you want to use. The model name you can get from Hugging Face. You can take any other model as well. And I have taken, in this particular scenario, I have taken all mini L6V2. This is the model that we'll be dealing with, or like looking into at the moment. And then we pass the sentences. Let's say this is the list of sentences that I want to embed, right? The weather is lovely today. It's sunny outside, and I drove to the stadium. The statement 1 and statement 2, if you see, do you think they are somewhat similar in terms of they are talking about weather, right? They are talking about something which is um, which represents some climatic condition or some weather condition. So if I talk about in terms of cosine similarity, the similarity between these two terms should be closer compared to the third statement, correct? How many of you are able to understand this concept? Maybe put it in the chat if you are able to understand why I'm saying that statement 1 and 2 would be closer compared to the statement 3. Statement 1 and 3, statement 2 and 3. Yeah, okay. So simple, there's no like much of a rocket science behind this. How do you convert it? So it's just that everything is available at your disposal. It's just that you should know how to use that particular thing. So if you do, you have already made this model object from this sentence transformer library, assigning the model name here. And you just need to do a model dot encode. This encode will do, in this encode, you can pass a single statement, or if you want to have multiple statement embedding at one, you can pass the list of statements, right? Here we have passed the list of statement. This is my list of statements, which has 3 statement in it, and I can have this embeddings ready. In this embeddings now, I have my all the embeddings that are available with me at the moment. So when I run this cell, I have already prepared this for you, because at the back end, this is going to download a model for you. Your um, in your local directly, there will be a model downloaded, which is equal to the size of this model. It can be some, like if you use different models, it can be sometimes couple of GB. Sometimes it can be in MBs also, let's say 700 MB, 800 MB, or like that, right? You can have that. So these all logs, if you see, these are all related to the size that the model is getting downloaded. And when I say what is the shape of my all embeddings, right? So here I have 3. So in return, what you will get, you will return 3 rows, where you will have each row representing one vector. So if I look into the shape of my embedding, where that's what I have printed in here. So see, this is the 3:84. This is the shape of my embedding. 384 is the length. Remember the thing that I mentioned in here. I'm not sure if it will be available. It is all erased. So this is the length of my vector that I mentioned. It can be 1024, it can 512, it can be 1536, depending upon the model you are using. For all minis model, the shape or the model or the vector length is 384, right? And if you see this similarities, so we are creating this similarity matrix, like how much similar my one statement or my one vector is with another. For first statement with itself, you see. So if you want to put, I'm not sure if I can write in here. Okay, so if you see this, this is my first, this is my second, this is my third statement, this is my first, second, and third statement. Now, if you compare first statement with first statement, right? The similarity is 100%, obviously, because the logic is same for both the vectors, right? And how this cosine similarity is calculated, it is again dot product divided by the magnitude. There is a formula behind it. We can go, or you guys can explore that in detail. But it's that the exactly the cosine similarity can vary between 0 to 1. 0 representing minimum or less, or not closer or less closer. 1 mean they are like overlapping. Anything between 0 and 1, if it is closer to 1, or let's say approaching 1, that means they are similar. How close they are depending upon the number. Let's say if it is 0.9, you can say, okay, they are very close in terms of the cosine similarity, right? If they are closer to 0, that means they are distant. The distance is huge between those terms, right? So it is all comparative, right? So if I see from 1 to 1, it is 1, that means they are overlapping, right? From 1 to, when I compare to statement number 2, the similarity is 0.6, right? You can say, okay, this is not very close, like the statement is not very close, but they are talking about weather. But if you see statement number 3, the closeness is 0.1046, right? So if you look into the comparative, 1 and 2 are relatively closer, 1 and 0.6, right? They are relatively closer compared to the vector 1 and 3 or 2 and 3, right? You can see in here, if I compare 2 and 3, the similarity is 0.14, right? So that's what we discussed in our theory. That's what our understanding was, and we can see that here in when we are implementing this in terms of code, right? So that is also applicable here, correct? Any doubts in here?
I have a doubt.
Yeah.
When you are comparing three sentences,
Mm-hmm.
it should create only one dimensional array, right? Why should it create two-dimensional array?
No, so it is comparing. See, that's what I told you. So the array is creating, it is first, second, third. So it is about similarity of first with the first statement, right? It is not that we are creating only one. Okay, here will be similarity of one with what? Like this is my statement one, let's say. Similarity of statement with what? There are other two, right? So it's like you are comparing one with one itself. Let's say you have same here. So you are comparing one with one, you are comparing one with two here, you are comparing one with three here, and then you are
Got it.
comparing one with two here. So these values should be same. Here, if you see, these values are same because
Okay, got it.
you compare one with two or two with one. It's the same thing,
Okay.
right?
So we will get some identical numbers, right? Like I can see all the diagonals are one, and
Mm-hmm.
there are 0.66. There are twice it is repeated. Can't we optimize it to have
No, so
to
in
just
general, no, in general, this is just for the representation. But in general, when you are doing a cosine similarity, you are doing between two statements, right? This is the method that I have implemented. But when you're doing a cosine similarity, you will get one number. You are giving in the input two statements, right? And in the output, you will get one number which is going to between 0 and 1. This will be the cosine similarity of this particular two statements, which you can take it further, right? So let's say in your database you have 1000 statement, right? Let's say this is 1000, and in the input you are sending one query, one statement. Let's say that was a user question. The user question was about, tell me about transformers, right? So this input will be converted into embeddings, just like the numbers that we have seen before. It will be, let's say, if we are using all mini model, this will be an array of 384 numbers, right? Now this list of number or this vector we will be using to send it in my database and get the cosine similarity. This 384 length of dimension of vector will be compared across each and every statement that is there in my database, and we will get some cosine similarity with each combination, right? So let's say this is my query with statement 1, query with statement 2, query with statement 3, query with statement 4. We'll be getting some similarity score across my database, and then I can filter it out. Okay, I want only with similarity which is let's say more than 0.8, because that's what the relevant information is, right? So if you see in this particular statement over here, in this particular statement, if I send something which talks about weather, and if I say, okay, get me something which is like, let's say, top one statement which is there in my database, right? You can filter it two ways. Either you can put a top k scenario, ki I want something which is closest irrespective of what similarity is. You can, if the even if the similarity is zero point 0.3, you want it depending upon your scenario. Or you want to say, okay, I want only if the threshold is more than, or the similarity score is more than 0.8. Because if it is 0.8, you are confident that, okay, whatever you are retrieving from the database, it is similar for your further analysis, right? That's what that's where cosine similarity is helpful. Got it?
okay? Yeah.
Yeah. Any more doubts in here we can take up?
Yeah, Ankit, Rajiv here.
Yeah.
So just already I confess that can you please tell me just briefly that the sentence converted to array.
Mm-hmm.
I know it. If you have 1 minute to help me to explain how the sentence, the concept between the conversion between the sentence and the array, because
Difference between sentence and array.
array that is converting to array, right?
Mm-hmm.
So 0 1 value.
No, so when we say when we are converting into a array, we have input text, right? That text is converted to embedding.
Mm-hmm.
This embedding can be of different length, 1024, 512. Right now we see it was 384. It can be 1536. This can be the length of my array. Or when I say array, you can take it like it's a list of numbers that is available with you, right? It will be a list of number with values like 0 0.4, minus 0 0.3, 1.5, minus 3.6. Like this, you will be having n number depending upon what model you are using. This is my vector, right? I'm using this term vector, array, list interchangeably just to help you guys understand that it is all about how you put this information. I can call it tensor also because it is holding that information that will be taken further for the processing. This natural language text was converted to these numbers, which is actually holding the essence of this particular text. How we are converting it, that a logic, that's an embedding technique that's we have also discussed in our earlier session. Maybe once you go through the session, you should be able to understand how these embeddings are created, how these
Yeah, yeah.
numbers are created, these number where these numbers come from.
Okay, okay.
Okay.
That's why that's because.
Yeah,
Yeah, yeah. Thank you.
no worries. Shall we proceed? So right here we saw how we calculate the similarity, right? Let's take another example, and let's say we are looking into, earlier we saw BG model. Now let's say, sorry, the all mini model. Now let's take a look at the BG small model. There are different models available depending upon the model. The size can also vary. I'm using this small model. The model can be large. I mentioned can be 384, 512, 768, depending upon what model you are using, right? Depends upon model to model. And when I say model, that means each model or each embedding model that we are using has some different technique or different logic of converting those text into numbers. That you remember that there was some static lookup table that we had. Each model has some different technique of creating those tables and creating those embeddings, right? So if you see here, we have two statement, two list of sentences. Sentence one, which has two dog and cat. The second was is Delhi and animal. So if we look into this and based on our understanding till now, which one do you think would be relatable? In sentence one, we have sentences like dog and cat, and in second one we have Delhi and animal. Which one would be closer compared to dog? Compare between dog and Delhi. What do you think the similarity would be? And then compare this would with dog and animal.
Dog and animal
With
has
dog
a
and animal.
highest similarity.
Not highest, but yes, compared to
But
dog and
yes,
Delhi, it should be much similar. Uh,
much similar, yes.
yeah. Similarly with cat and Delhi, it should be at some distance compared to cat and animal, because they should be even like more closer,
Yeah,
right? So that's what we can see in here. If you compare, so over here we have, like, similarly we have created this object, sentence transformer object, passing that model in here. So you see, I just changed the model name here, and my model and my everything embedding and everything was changed for this particular scenario. So it is as easy as what model you are changing, but changing the model is as easy as changing the name here. But the use case can completely vary depending upon the model you are using, right? The length of the vector will reduce or increase depending upon the model, right? So if let's say compare, I encoded my uh, sentences, the list of sentence. This is my sentence one, and this is my sentence two that I have converted into embedding. And now I'm trying to find the similarity between these two list of sentences. And if you see in here, um, yeah. So if you see that similarity between, let's say this was the similarity that we have got, right? So if you compare the word dog with Delhi, this is the similarity that I am getting, 0.49. Compared to my similarity between dog and animal, this is the similarity that I am getting, 0.92, which is closer compared to my dog and Delhi. Similarly, if I do cat and Delhi, it is at 0.54. And again, compare with dog with animal, it is at coming at 0.77. So we can clearly see that the difference exists in terms of the concept that we are putting in the embedding and trying to find out the cosine similarity between those vectors, right? And here the length is again 384 for this particular single vector, right? So this is like different model, similar implementation made so that you guys can understand what is happening here. And if you see, if I use some open, till now we were using open source model. You can just take the names, what model you want to use from Hugging Face, and it is as easy as just running a single notebook, right? But when it comes to the OpenAI models, you need to have those OpenAI key, you need to pay them to access those models, right? And you need to implement it. So this is how we can implement the code for converting text through OpenAI embeddings, right? The model name is this. This is my model name that I'm passing. This is my input statement that I want to convert into embedding, right? And now once I run this cell, I'll be having OpenAI embeddings that are available for the further use.
So, Ankit, I have a
Yeah.
one question, not a question, it's a request that,
Mm-hmm.
like if I say, like if I create any model,
Mm-hmm.
you know, either in a deep learning or as a machine learning,
Mm-hmm.
there are some steps which we need to follow, like
Mm-hmm.
get the data, get the data, then pre-process the data, then create a model, then train the model, then test
Mm-hmm.
the model, right?
Mm-hmm.
And then fine tuning it by using different fine tuning it. So these are the some steps which actually, whether I create a simple model or create a complex model, these steps has to follow in a same manner, that people collect the data, then I will pre-process it, and then create a model, then I'll train the model on the data, then I'll start testing it, and
Mm-hmm.
start and then find the fine tuning it. So is there any steps which, if any application, if I want to create on a using a gen AI, okay, based on the gen AI, so there are some steps, like at the initially we understand, okay, this step I need to follow first, then I will go for second, then I will go third. So it will become in a habit to write the application code in a proper professional manner.
Mm-hmm.
So is there any
So
kind of steps we have generally which we need to follow?
okay, so till now we are understanding how a model would work, right?
Yeah.
We are not
Mm.
actually gone into implementation. Just now we have started how we are going to implement the model, right?
Right.
So it is when we go further, we will be doing some implementation. We will be also building some projects around these scenarios. The cosine similarity is one of the concept which will be incorporating in our projects, right? When we are building, let's say, some chatbot where, let's say, we will be doing a project where you can just upload a PDF and start interacting with the PDF in just like 2 minutes. Everything will be ready in the back end, right? And this will be implementing this project in our coming sessions, right? So for now, till now, we are just discussing on some of the concepts. These are important when we are building any application or any use case. Okay. Yes, no, hello. Okay, I'll move further. Okay. And yeah, so looks like there's some issue with my API key, but that's one of the problem that you will encounter, that sometimes these kind of issue you might need to debug. I am getting the error that incorrect API key provided. The API key that I'm using in here is not valid. So now what I need to do, I need to go back and check if the API key is correct or not. I need to get the correct API key and use it here, right? This is how you can use that scenario. And once you have it, I'll not debug it because then it will take time, and I don't want to waste the time. We are already late in terms of our sessions, right? But the length of this OpenAI embedding would be 1536. The code, the line that I have mentioned in here, it should be 1536. And this is equal to, or this is same as the length that we are mentioning in here. So this 384 length is capturing the meaning of a statement there also. And one thing to highlight in here is, let's say you have a statement which is of, let's say 10 characters, right? You have a statement, something like, let's say, which is of 50 characters. And when I say character, I mean this A, B, C, these are one character, one space is one character, right? And then you have another statement which is of 500 characters, right? And these again, characters are same. So now if I convert this into embedding and I convert this into embedding, what will be the size of embedding of these two? Can you guys tell me what would be the size of these two embeddings, or these embedding of coming from these two input text? One is of 50 character, other one is of 500 character. What would it be? Are you guys even there, or I am just speaking alone?
Both will be 1536.
If we are using OpenAI,
Yeah.
it will be 1536. Any other, let's say if I'm using all mini for both of them, uh, let's say not the number exactly. Do you think the length of these vectors will vary when I convert them into embedding? What would be the length? Will it be same? Will it be like smaller for this one and bigger for this one? Or is it going to be otherwise, or what it would be like? Let's
It
say
could.
equal or unequal.
It will be equal.
Why?
Uh, Not sure, but like I think like this embeddings will be representation, right? And that the
Hmm.
length will be same for all the
Hmm.
words that it. I mean the embeddings that it generates for each and every
Hmm.
characters are like this. That's what I'm thinking.
Okay, correct. So it depends upon the embedding model. The length of these vectors are fixed. If there is too much of information inside that, let's say this 500 character was too much of information, this will be fitting in my 1536, right? And if I have 50 also, it will be fitting in the same, let's say I have this one module which is prepared, and I need to fit whatever the information is coming in inside this only. There can be too less of information, there can be too much of information, right? If there is too less of information, you are wasting the space there, right? When it comes to actual comparison, you will be having some extra spaces available, which is actually not correct. And if you put too much of information inside that 1536 window, you will be what do I say? Um, Diluting the embedding for that particular sentence, right? Or for whatever the information is coming in. So when you go and search for this particular embedding with with 500 character with some of the statement or some of the word that is available in here, you might not get a good score in terms of similarity, because there is other information that is available which is diluting the embedding for this particular single character or single word in this statement, right? So it is generally said that you should not have too much of information inside a vector, not too less information. It's just that you need to have just enough information so that your vector is doing that similarity. You are able to get to optimum similarity, right? That was about embedding, right? You can explore. I'll be sharing this notebook as well. You can explore this different embedding models out there, and you can get a hands-on, because we'll be using these models, some of these models, in our further discussions, right? So till now we were into embedding and cosine similarity. This was the major part. Rest of them won't take much time. Mm, okay, we are already 1 hour into today's discussion. We should speed up, guys, or I should speed up. Let me know. I'll be uh, discussing. Whenever you feel doubt, just stop me and we can discuss that, right? Rate limit is something, how much request, or let's say you can say token per minute. How much tokens per minute a model can generate. That's the rate limit of that particular model. Or how much request you can throw to a model. Let's say in terms of OpenAI, there is a limit on how many requests you can make within a minute to the model, right? You cannot bombard it. If you are hosting your model locally, you can bombard it. But if you are using the OpenAI models, you cannot just throw n number of requests within a minute. There is some rate limit, and along with that, there is some also token per minute limit that a model can generate. This token per limit depends upon what model you are using, what hardware it is, what service you are using, open source, closed source, and all that part. But there exists something called rate limit of a particular model. Just yesterday, we were trying to create vectors of around 15 to 6, 15,534, if I remember it correctly. So this was the number of vector we were trying to create, right? It was 15,354, around this only, right? And we were trying to create vector for this, and it took us around 10 minutes using OpenAI, right? So this is like we were taking one vector, one word or one statement at a time, converting into vector and storing it down in our vector databases. Vector database, some of them we'll be discussing further. So vector database is nothing but where we can put this vector that is embedding, that is converted, to store them efficiently, so that we can, whenever we want to retrieve, we can efficiently retrieve. It also supports some of the concept like cosine similarity. You need to know to do additional calculations, additional efforts for that. It is already available you along with the vector databases. Temperature is something that I think we have discussed, but I'll reiterate. So temperature, like let's say you have a statement that is going inside your, let's say this is a text statement that is going inside your large language model, and then you will have some predictions, right? Large language model predict one token at a time, right? So it will predict one token, but it actually does not predict one token. It actually predicts a couple of tokens. Let's say it predicts 10 tokens, and these tokens will have different probability, all adding up to 1, maximum 1, right? This will be so it will be like what could be the possible token next to this particular sequence of statement that is there in the input. If you set the temperature on the higher side, that means you want model to pick up some of these uh, uh, probabilities which are not the highest, right? You want to make the model go random sometime when you are doing some storytelling or you are doing some creative kind of work. You want model to be more innovative, not just be very specific to something what it is doing, right? But if you put the temperature on the lesser side, you want the model to be very specific. So it should pick up only the tokens which has the highest probability. So if you put the temperature to on the higher side, it will be more randomness. Random model will randomly pick up probabilities or the tokens with lesser probabilities also. But when you put it on the lesser side, you want model to be more specific. So if you run the same model, everything remains the same, and that you put a temperature, let's say on the lower side, the output would be largely the same. The token that would be predicted here would be the same, because that's the token that has the highest probability. The token will have the same probability if you run the sequence multiple time also. Condition being all other scenarios remain the same, right? But if you do a randomness, not necessarily if you run the same sequence, everything remains the same. It's just that you run it again, you might get something new altogether, right? So that's the concept of temperature, and it is helpful in some of the scenario. It is very like absurd in some of the scenario. Like if you want to have some text to codes kind of scenario, you don't want your code to be very creative, right? You want a very specific code. If you want to write a code to add two numbers, it will be the same code. You will do the sum a plus b, right? You cannot have the scope of creativity in there. But if you are writing some, let's say, some campaign or some creative kind of work, you might need some high temperature in that case. And the range of this temperature can vary depending upon model to model. Some of the model has temperature range of 0 to 2. Some of the model can have range from 0 to 1, right? Some of the model doesn't allow you to have a temperature of 0. So you might need to put 0.1 or 0.001, right? Depending upon model to model, you can have the OpenAI supports this 0 to 1 kind of scenario, right? 1 being the higher side, 0 being on the lower side, right? Clear on the temperature part? Any doubt, please speak up and I can move to the hallucination. Hallucination is something, let's say you have trained your model on data, let's say till Gen 25, right? So your model knows all the details or whatever the data that you have trained it on till January 2025, right? But if you ask something about the event that has happened in April 25, this is a classic example. If you ask something about something that has happened in April 2025, model is trained to predict the next token, whether it is correct, whether it is not correct. uh, Model is not too much into the correction part, right? Correction is something that human needs to validate. We try to go as close as the correctness, the accuracy, but even after running the same sequence, temperature, everything remains the same. Sometimes the model can produce some of the information which the model itself doesn't have understanding of. So that's what we call hallucination. I'll give you a classic example of this. At my organization, we are building something called text to SQL, right? Passing the same information, same context, everything remains the same. The output query that is generated can be different. The SQL query that is generated, it can be different, right?
The same kind of a project we are also doing in our BU.
Okay, great. We can discuss on that definitely. But
Because
you must
the
be.
things like a chat box, you just
uh,
give a simple text box, it will write a query, get the data from DB,
mhm,
and show you it in the chat box.
mhm. Exactly. So you must be aware, like even after putting everything, all the parameters, everything remains the same. The query or the output can vary, right?
Yes.
So that's what. Sometime it is correct, sometime it is not correct. So that's what my hallucination is. That model, even after putting all the randomness, model can produce something which is not in the capability or not in the expertise of the large language model. It can produce that because it is trained to produce the next token. So it will produce something or the other, right? So it is up to the humans to validate whether the output was correct when it, and you, the good part is you will not even know whether it hallucinated or not, right? So this is one of the what I would say. That's why, because of this hallucination, many organizations are skeptical about adopting the large language model. But as the time has evolved, the large language model has evolved. This hallucination has reduced to a lot, but not eliminated completely. It still exists, right? Now, if we talk about prompts, uh, prompts is something what you put in the input, right?
Ankit,
Uh,
before you move forward, I had a doubt.
yeah.
Is there any limit to convert any text to embeddings?
What kind of limit?
Like, uh, like I have using a 1 lakh of tokens and converting into the embedding,
Hmm.
and in the other case, I have using 10 lakh tokens and convert into the embeddings. Is it
Hmm.
limit like we can convert only 5 lakhs of token at a time into the embeddings?
Okay, so that is something I have not explored yet, because when you are creating a embedding, you also need to take care of the dilution of your vector or
Yes,
the
it
embedding that you are creating, right?
yes, yes,
But I don't think there is any such limit. From a practical use case, you would not want to put 10 lakhs tokens for the embedding, but if you want to explore, you can try. I don't think there is such limit exists, but maybe you can explore and share with all us as well.
Yeah, but at the end, it is doing something like time and study reduction of the.
Yes.
Yeah, that's. I think it might be uh, okay if we use any number of tokens to
You can use any number of tokens in the input. I don't think there is such limit of how many tokens or what is the length of the input that your input text, let's say, you are giving when you are converting into embedding. It's just that whether that output vector actually hold that essence of that particular um, statement or the input that statement that you have given, how good it is in that term, how good it is in terms of use when you are going to call that vector, right? The application use case of that particular vector that will decide what should be the input length, right? Yeah. So coming to the prompts, prompt is something that you give in the input for the model to do something. It's like you are asking, let's say you want to write a program that adds up two number, right? So maybe best by giving, let's say, write a Python program to add two numbers. This is the prompt. This is the instruction. This is the question that you are asking the model to work upon, right? This is the input text. This can include all the information that you want to give to the model, and the model should produce the result, right? If the model is not producing the result as per the expectation, maybe you want to improve the input that you are giving. And when I say input, it is the input text or input like image, if you are working around with image, right? So whatever the input that you are providing, it should have enough context to answer what you are asking. If it does not have, you might expect the model to hallucinate, right? So that's my prompt. Prompt is something that you give in the input, and this depends upon model to model, right? How you ask them. Let's say if I want to instruct someone to do something, right? Let's say I have my like one intern that is working on the same project along with me, and I want to pass on some instruction for that particular individual or particular person to understand and work on something, right? So I need to give enough context for the other person to understand, right? Similarly here, for the model to work on something that you are asking, you need to provide enough context. The way you provide that context also matters, right? If the model or if the other person is able to, it's not like I have provided, my job is done. It's not like that. The other party, like in this case, the large language model also should be able to understand what you are referring to. So maybe you want to use the dynamic language, or you want to use something which the model is able to grab faster, right? So let's say for large language, so in terms of large language model, you might want to put in the statement or your sorry, the prompt should be structured in a way or in a fashion which the model is already aware of. And how the model would be aware? Through its training or through its pre-training or through its fine-tuning that you have done, right? Or the fine-tuning that is available. So if you put the prompt or the question or the input that you are asking in some of the similar format which the model already understands, right? The model tends to perform better. And there was like a study by Anthropic, and they have found out that giving the context prior to what you are asking makes the Claude model perform better. This is Claude is one of the large language model that is available by Anthropic, and they have this study, and they have published it, that if you provide the context before you ask the question, the model tends to understand better, right? That's how sometimes it can be like what you want to ask. Like for OpenAI model, you first defined what is the specific task that model needs to do. Clearly in the starting instruction that you are providing, clearly mention what the task you want the model to do, and then put some instruction additional. Let's say there are some guardrail that you want to put on, and then you ask, maybe you want to give some examples also. That's what we called a few short prompting, where you are putting in some example also for model to refer, right? So that let's say when a intern is working on something and you also give some projects, as it is similar to if I take other example in our maths book in our class 10th, right? There was some examples along with the questions that are coming up, right, in the exercise and solve problem. So you can take the reference from the example, solved example that are available, and approach the questions that are available, approach the question that is given to you, right? Similarly, in here, there is something called zero shot prompting and there is something called few shot prompting, where in zero shot prompting, you do not give any example to the model, and the model is required to work on the instruction or the context that you have provided. In zero shot, in few shot, you provide some example to the model, so that model can follow that pattern or follow the understanding from the example and produce you the results, right? There are more type of prompting, some like chain of thought, where you can pass how to think to when you are approaching a particular problem as well, right? I have also prepared a notebook around different type of prompting, so maybe we can take a look how to write a good prompt. And I'm not sure if how many of you are aware of, but these days this prompt engineering itself has become a good field or one of the lucrative field, um, or job role itself in the market. Prompt engineers are paid really well as well, right? So it's about how you pass those instructions to the model, right? So your input should be, this is the input used for AI model to get the specific response. Prompt should have proper instruction for the model to understand what needs to be done. Clear and defined task, defined role. So the role is like, let's say you want to have like a model that is doing an advertisement campaign, right? Or let's say you want to do some search engine optimization, right? So you want to assign a role to the model. How you assign a role? You just say you are an expert on something, right? And you pass in that something, whatever something. You can be a data analyst, you are a manager, let's say a technical manager, you can be a search engine optimization expert, you can be a product manager, you can be a client facing, let's say, desk manager or something. So it's like how you define a role. This is found out that if you assign a role to the model tends to perform better, because it's like you have understanding of lot many things, but when you are in your office, you have that head that you have expertise in certain skills that you are working in there, right? So you're automatically you are into the zone. If someone randomly takes up some of the words that are available or something talks about something that is in context to specifically to your office, you quickly grab it, right? But if you are at home and someone talks about something that is not very relevant to your home environment, you will be surprised of what has come, right? So it's like you define the context, you define the role for model, so that model tune or model adjust according to the task that is going to come up, right? That's how what you define the role for the model. And it has been observed that this assigning this role tends to makes the model to perform better, right? So that's why this is a good practice as well. And you only need to add enough context. It should be precise, it should be clear, and just enough context for the model to understand. When I say context, let's say you want model to write a ad campaign or do something with the search engine optimization. You want some of those keywords, you want some of the ideas, right? So maybe you want to put in the context. Okay, I am trying to build a website. What the website do, what is the context, what is the business domain that the website is working, what is your target audience, how what is your budget, maybe if you want to spend around that, right? So all of those scenarios you want to put in the context for the model to understand, and then you can expect the model to perform better. If you do not provide that context, it may or may not work as per your expectation. But if you provide more context, more relevant context, it is not about more context, it is about more relevant context, the model tends to perform better in these kind of scenarios. And it is not just with any specific model, it is across all models of how you provide this context, right? So you should beware when you are writing something. So from now onwards, whenever you are using chat GPT or something, just try to add that context, or I won't say just try, but you should definitely structure your input the way you are asking the question. Just structure in a good sentence format, maybe assign a role, clearly define what the model needs to do, maybe define your problem statement as well, what you're trying to do, what you're trying to achieve, and you are not able to try to put it in a clear and concise statement, and then see if the model is picking up it fed better or not. I'm sure it will pick. We are doing that at like day-to-day basis as well, right? So the structure format can vary depending upon model to model, right? Just like in OpenAI and Claude, I mentioned where your problem statement should be. Should it be in the starting? For OpenAI, generally it is in the starting. For Claude kind of model, it should be somewhere towards the end. It's not like if you do not follow this pattern, the model will not work. Model will work, but to get a better performance. It's how these are some of the techniques that are out there in the market, which are tried and tested by enterprises, and these are some of the good practice that are available, which you can grab and start working on them, right? Then there are some of the prompt technique like zero shot, few shot, as I mentioned. So let's say example of zero shot prompts, like classify that natural text into negative or positive, and then you put in the text. You're not giving any example. You're just mentioning, you are clearly telling that what needs to be done. You need to divide into neutral, negative, or positive, and then you are putting in your statement. And then you can expect the model to return some answer, right? In few shot, you are also putting in some example for the model to understand of how the model should perform, right? So let's say in this particular scenario, so it's what poo is a small funny animal native to Tanzania. An example of the statement uses the word what soup is. So this is my statement, and this is my we are traveling to Africa, and this is my, like, let's say, question, and this is the example that we are putting in, right? Similarly, just the way we have added this statement in here, we are trying to take the similar kind of format in here, and then we can expect the model to perform in, or like let's say take the guidance from the example that you have provided and work in that fashion. We'll be seeing how this to make a difference, right? And then comes the chain of thought. Chain of thought, that means you are guiding the model to how to approach a problem. It's not just the question and answer. In few shot, we were doing what is the question, what is my answer. But in chain of thought, we are also providing how to approach to that kind of problem statement, right? So if you go through the odd number in this group adds up to even, right? This is my input sequence, but how to approach that problem? Here it is, adding all odd number is 9, 15, 1 gives us 25. The answer is false, right? You have defined in this particular statement, you are also defining how we are approaching the problem, or how to understand that problem statement that has been provided, right? And then you ask the question, how, like, if that this particular sequence adds up to even, right? The odd numbers, and then you expect a sequence. So this is your input question that goes in, and you can expect the model to follow the pattern that you are providing in here, right? Along with it, I would also see if I can get you these statements running. Yeah. So the next topic in this particular thing is also called parser. Parser is one of the important concept in terms of when you are building any use case application around generative AI, because the model is predicting, model is giving you the output, but how you can use that output is the challenge, right? Earlier model were not very friendly with the parsers, but with the time the model has become quite handy to work with parsers. Parser is something, if I give you in terms of concept, parser is something, let's say, let's see in the example itself, you will be able to understand that better. So this LangChain Grok is open source. Grok is something which have hosted the models for you. You can just use their library and start using those models, right? So what parser does is, output parser is responsible for taking the output from the LLM and transforming into more suitable format, right? So if I give you with an example, here is the same example that we have used in our previous prompt scenario, that we need to classify into neutral, negative or positive, and this was my statement. And see, this was the output that I have got. I am just using my prompt. I am passing this prompt and I'm taking the response out of it. So this is the complete response that I have got from the model, right? But do you think if I need to build a application which is sentiment analysis, and the output should be just one word, either neutral, positive or negative, and based on this you are taking some additional action, right? But if you get this much text in your output, do you think you will be able to build that application? No, right? So that's where the parser comes in. Parser will take this information, or parser will add on some additional instruction when the question is, or the input text is going inside the model, and it will ask the model to structure the response when it is coming out, right? And you can easily extract that information from the response. So if I use it without a parser, I'm getting this kind of response, right? But let's say if I am putting it with the parser, this is where I have defined my parser, right? I'm using a sentiment classifier, right? So I'm using a base model. So this is the code implementation of this particular thing, right? For configuring the large language model, if I talk about this briefly, I'm using this library called ChatGrok. This is an open source package available from LangChain. You can use that. So how many of you understand what LangChain is? Or first of all, tell me how many of you think the information that we are discussing, it is going a bouncer, or it might be overwhelming? Shashwat has no idea. Okay. Any other else? Yes, I know. Okay. Do we have people in the session, or all everybody is?
It's going to bounce, but a little bit understanding into that. And
So yeah, so I would share all these notebooks. Don't worry about that. Just try to understand the concept at a broader level for now. And when you go through the notebook, I'll share those notebooks. You should be able to run those notebooks. Just see how this is implemented. If you encounter any error, before reaching out for any help outside, search on Google, right? Just see how this is implemented. This is like simple. You can get this code directly on the LangChain itself. Okay, for those who do not have idea, so it's like a Python library that is available for you. This is an open package. So right now, if you would have seen in our earlier notebook, for creating those embeddings for different model, I was using different template, right? I was creating a model object and I was doing model.encode. For OpenAI, I was doing completely different thing. If I can pull that notebook up, just give me a moment. It's a good time, I think, to understand why LangChain is important, and why we are LangChain is one of the widely used libraries when it comes to AI, generative AI. So see, for generating the embedding from my OpenAI source, right? I need to first create a object, and from that object, I need to pass client.embedding.create, and then pass my these parameters, right? Let's say tomorrow you want to change the model. You need to change everything. How you call the model will change. Everything will change, right? Let's say let's if we see in here we were just making the sentence object. We were not passing the model name here, right? In our OpenAI scenario, we were not passing the model name here. The library was completely different. But once, let's say, I created my object with some configurations, I am using it in different ways, right? For sentence transformer, I am using model.encode. There is one pattern for one model, and there is another pattern for one other model, right? So it's like uh, you are building but how can I put it in? I'm trying to look for some good example uh, where we can. So I'm not able to think of any example for this at the moment. But you see, if mm, I create a object to access these models, I need to have some process or some methods which I need to follow, right? For OpenAI, the using the technique can be different. For the other model, the technique can be different, right? So what LangChain does is it gives you that overall wrapper. Internally, it can configure all the matrices for you. You just need to configure it at one place, and you can use it exactly the same way for all the scenarios. You need not to worry about how this is handling it internally. This LangChain is handling it for you. Once it is configured in LangChain, you can use it, and you can be assured that if your embedding model is changing, you just need to change one thing, that is your this object. If I change this object to something else, this is my LangChain object. If I change this object, rest of the things will remain the same. It will not have any impact on how my rest of the code is using this particular object, which is my large LLM in this particular scenario, right? So that's where the importance of LangChain comes in. How many of you are able to understand what LangChain is doing? Because this is very important moving further, because we'll be using LangChain aggressive, like in, I would say, all of our scenarios, all of our
So
sessions now.
my understanding about the LangChain is it's a LLM model which is used for task specific classification like text to text. So if we are using in a GenAI based application, that means we are telling that model that this is my task, right?
Mm.
Like I give some text to my LLM and it will give me a content as a text as
Mm.
output.
No, okay, so I beg to differ in here. LangChain is not a model. It is just a package. It's just a bunch of files of Python code.
Okay.
Internally, it is creating those classes, those objects, everything is ready for you. You are still using the model, large language model, which is outside the scope of large this LangChain, right? You can use any model that is supported by my LangChain,
Okay.
right?
So basically, it's kind of a library which, like
Yes,
we have a library in the NumPy or Panda
exactly, exactly.
library. Just
Similarly,
we need to
it's a
call the
library.
methods which has been written.
Perfect. This is absolutely what I was trying to explain, that it is just a library. It is just a package. It is just a bunch of line of code that is written. You can use it internally. You need not to bother about how to call a model. Already, all you know need to do is, let's say you create a object, LLM object, which is a LangChain uh, object, right? Once this LangChain object is created, even if the model is different, let's say you can use OpenAI model,
Okay.
or you can use Grok model, or you can use Llama model, or you
Mhm.
can use some Claude model. Any model you can use. Internally, you can use any model, but on the outside you have this LLM object. That means for accessing all the models, all you need to do is LLM dot invoke, and you need to pass your information.
So why then we call LLM LangChain as a LLM model?
No,
Why we call it?
LangChain is not a LLM model. LangChain is just a wrapper. It is just a package. It's a wrapper
It's just a
around
wrapper that
different.
you can
uh,
call any LLM model by using
Yes.
Lang. Just
Internally, it is using actual like, let's say for OpenAI, internally it is using actual OpenAI implementation, how to call the OpenAI model.
okay.
Internally it is using, but it is taking away the headache from you to change the complete code base if you want to change the model tomorrow. You need not
Okay.
to worry about that. Today I'm using OpenAI. Tomorrow I want to go open source. I want to use, let's say, Grok models, or let's say I want to use Llama model or some of the self-hosted models. You need not
So
to
okay.
worry about rest of the thing.
So my understanding now is that LLM is just a wrapper that you need to just use your
Not an
ops.
LLM. It's a
Not
LangChain.
LLM. Okay, a LangChain. So
LangChain.
LangChain is work as a library which work as a wrapper for any kind of a LLM model, which we can use it by just creating using a object-oriented programming concept,
Hmm.
like
Correct.
creating a object of
Yes.
LangChain, and by using that object, we can access any class of the LangChain or a method has been written into the
All the
LangChain.
methods available. Correct. you
and
can
we
use it.
can call any kind of LLM model by providing information like which model I am using it, the API of that model. Like if I have an
Exactly.
OpenAI,
You
then
can
I have
configure everything in there.
on that basis just like a
Yes,
normal programming, kind of a programming which we do in Python, Python or any
correct.
language.
Exactly. It is exactly the same thing. It is just a Python package, just like any other package you would use. It can configure the backend large language model configurations for you. Yeah. Uh, just want to clarify, everybody is on the same page. If anyone has a doubt, please speak up right now, because moving further, we will be using LangChain in our, like, I would say, majority of our sessions.
Can you please
Clear?
also explain a little bit about Grok?
Yes. So Grok, this, if I talk about Grok, this chat Grok I'm referring to here, or Grok, it is a like a platform hosting model for you. They are hosting model for you. You need not to all the open source model, not all, but some of the open source model. Let's see if we can take a look. You see this? There are these open source models. Let's go on the developer side. I don't want to log in. I don't think without login it will let me use. You see, these are all the models that they have hosted for you. Not all the models would be here, but these are some of the models that they are hosted, and you can use it. There is a limit to which you can use them. Not You cannot use them infinitely, right? They need to earn also. It is not completely free service. So you can use it till a certain threshold, and after that you need to pay. You need not to self-host your model. You can use these models, right? And they are one of the fastest in terms of number of tokens. The rate that we have discussed earlier, their is good. They are using something called LPU, language processing unit, instead of GPUs, right? So this was about Grok. You clear? uh, okay.
Yes.
So like OpenAI, where we deploy the model, right?
Yes, OpenAI is hosting the model. They are not available anywhere else. They only OpenAI can provide you the service, or there's OpenAI or Azure. OpenAI. OpenAI is hosting those models on Azure as well, right? But these models, you can have these models in your local hardware also, but you need to have that like enough resources in your local hardware as well, so that you can run those models. Or you can use some publicly hosted, like someone has hosted the model for you, like Azure is hosting those model, E2E is hosting those models. You can pay them and they will host the model for you, and you can use the service. Grok is similarly, some of that Grok is good in terms of inferencing. The inferencing speed is quite good in terms of in terms of other competitors out there. And they are also providing, let's say, if we want to learn, we are not building some uh, company application or some use case there, right? It is just for our learning. All of us might not have enough resources to invest in, right? So we want to okay, experiment with LangChain Grok. So we want to experiment with Grok. Okay, it is available open source. I need not to pay much. I can use it, right? That's the benefit of using this LangChain Grok. And when I say LangChain Grok, so it's like LangChain plus Grok. Similarly, you will have LangChain OpenAI also. This is LangChain Grok. किधर गया? Uh, just like this, LangChain Grok. Internally, it is using Grok. You did not to download anything and everything. You just need the specifics. So that's LangChain Grok. Okay. So I was referring to the parser thing, right? So this is again some of the class that are available for my from my LangChain. How to use those parser based model is one of the class that your input should be in a defined way, your output should be in a defined way, right? So this is the format that you define in, right? And if I want whatever the response that this is the response that I am getting from my model, I am doing that model dot invoke, and I have configured this model along with my parser, right? This is my sentiment parser that I have created. I have the response coming in from my model. The response, this object will contain the response that is coming out of my model. And I can simply say response.sentiment. Sentiment is something that I have passed here. So if I want to build an application, I want to check what was the sentiment coming out from this statement. I just need to do here model dot this response dot sentiment, and I'll get whether it was neutral, whether it was positive, whether it was negative. It should be able. So it's like integrating this whole thing into application point of view. Earlier, when the models were not compatible with the parsers, just 1 year back, whatever the response was coming out of the model, just like in this scenario, we need to clean it manually to extract what has come outside, right? We need to manually do all that effort. Now everything is internally. You need to just focus on adding that parser and start building your use case. So it is getting easier day by day in that term. Okay. So by now we are through with all the terms that are that I think for now to start with are important. These are the terms that we'll be using quite regularly in our further sessions also. Discussed as we have already discussed what LangChain is. Similar to LangChain, there is another called Llama Index. Llama Index is not as popular, but it is also one of the package that gives you similar kind of use case, right? LangChain is something that is widely used. In our use case, at my organization also, we are also using LangChain, right? So this was from the previous session, and we are already 1.5 hour, and we are still discussing the concept from our last session. Okay, do we have any more question, and then we can proceed? We can take a 2 minutes of breather. If you have any doubts, we can take up, and at 8:35 we'll start from the next the agenda for that was scheduled for today. How many of you are able to understand these terminologies? And the terms are not going as a bouncer. What the term means, what it actually is. You should be able to have some understanding of these terms by now. I won't say some, you should be better, but it's okay. Maybe put it in the chat. How do you feel now? Are you guys there?
Yes, yes.
Okay. Shashwat says comfortable with the terminologies, understood. Okay. So till now we have understood the basic terminologies that we are going to come across mm, in our day-to-day sessions. For building any AI application, these are some of the terminologies you should be aware of. There will be more terminologies, more concept coming up, but we will discuss about them as and when we encounter and the use case comes in. Right. Let's move to the agenda for today.
So again, just one question. It's not related to the anything which we have studied. Okay.
Mm-hmm.
So, like you are working in AI ML part, right? In the
Mm-hmm.
Gen AI
Yeah.
infrastructure. So, my question is that when we creating a kind of a deep learning model, ML or any kind of deep learning model, we are creating it. So there is
Mm-hmm.
a huge data is required to train the model or training or testing the model, right?
Mm-hmm.
And
Yeah.
for that, either we go for the epoch, you know, uh, the epochs or optimization, or whether we are going to use the GRU. So, are you using systems which is, the, not the CPUs? They have good GRUs into GPUs, or you are working on any cloud environment where the whole environment is giving you the GPU capabilities, or which kind of a
So,
system you
so
use?
currently, so this is a little off topic, guys. But just to briefly tell about this, we are currently primarily on Azure. We are hosting. We have fine-tuned our model, and they are all hosted on Azure at the moment. We also have something where we can put it in on-prem, but currently we are on Azure.
Okay, so basically whatever we do is completely on cloud environment, which have
Yes.
everything like GPUs, good GPUs, so
Yes.
you can have models and everything.
Yes.
Because in our organization, what we do, we have a the Amazon Bedrock, which
Bedrock. Yeah.
gives us a complete container environment
Mhm.
to uh, use Copilot or Anthropy. We use basically Anthropy. To the
Mhm.
Anthropy, we use LangChain in our
Yeah.
model, in our
Mhm.
Gen-based API. But
Right.
that is the reason I asked, because the coding which we do is on the Jupyter notebook.
Yeah. Correct. Yeah. That's I believe more all the organization would do. Malab, you're getting right.
Yeah. Okay. Thanks.
Okay. Yeah. So moving on to the agenda that was scheduled for today. I don't think we'll be able to finish it. Because for today's, I have only 4 or 5 slides, but again, the hands-on was on the majority. My hands-on would have taken majority of the time, but I'll try to finish as much as we can, and then we can start tomorrow. I'll request everyone to be on time in our today's session because we will be having a lot to discuss tomorrow, right? The topic that we had scheduled for tomorrow itself was huge, but we have something to overlap as well. But I don't want to push things for the coming week. I'll try to put things in tomorrow's session itself. Okay.
Or we can come one hour earlier. We can start.
We can see that
Everybody.
it's not just about you and me. There are everyone in the
Yeah, that's why.
session.
Though I'm just giving a suggestion
Mhm.
on that. If everybody is okay with that, we can start session 1 hour ago, like from not 7 to 7 p.m. It will be from six p.m. We
Yeah,
can
we
start.
can.
We can
Mhm.
on track.
Yeah, we
If
can see if we can have that
everyone
extra
like.
session. Yeah, no
Okay.
worries. We'll work around that. Yeah. So hugging face. Before starting anything and everything from for our today's session, the most important thing would be the hugging face. What hugging face is? Does anybody has any idea what hugging face is? Maybe you want to discuss with us?
Hugging Face is kind of a same kind of a lang chain, which is a framework, and provide space to upload deploy our different models, which we can use the same way the lang chain we are using it,
Mm-hmm.
as a lang chain as a framework to use different kind of a model. The same kind of a Hugging Face. Only the difference is that Hugging Face is a open community, that if I want to create my own model and want to deploy it, I can directly deploy it. And if I want to get any kind of model, whether it's a multi-model or single model, text to text or text to image, any kind of a model, I can directly go to the Hugging Face and access those models without paying anything. But in the LangChain is a different thing. If I'm using any model, if there is a cost associated to that which I need to pay it.
Right. So how many of you understood what hugging face is? Shamshir helped us give a broader overview of what hugging face is. Except from the part it is like LangChain. Rest of the things was to the point. I'll brief it again for you guys. Hugging Face is something which is a store for you, you can say, where you can put your models. And when I say model, these are the trained model that you have trained on your, like these can be your large language model that you have trained on locally, or you have you fine-tuned your models, right? Or you're a machine learning model that you have trained on your local hardware, local system somewhere, and you want to put it there somewhere so that publicly anybody can use it, or only the restricted people can use it, right? So it is like a store for your models primarily. It was built, but with time it has evolved as well. But primarily it is about where you can store your models. It can store your large language model, it can store your embedding model, it can store your machine learning model, it can store your natural language model, it can store your transformers model. All of it, you can store it on your Hugging Face. Along with that, there is also for the past couple of years, there is also something called data sets you can store on Hugging Face itself, right? So Hugging Face is just a hub, just like in the name itself. It's a hub where you can store your different kind of models, machine learning models that you can make public. Anybody can use them, right? So that's the Hugging Face. Uh, you can use it with the LangChain as well. LangChain has also provided those frameworks, but the Hugging Face itself has some of those functionalities available where you can use those. Like it has its own package. It has its own library where you can directly use those models, passing just some of the basic credentials. So how you can access is, I think one of us was having some difficulty in accessing the model or accessing the data set or model on the that is available out there. So there is something called public, and there is again something called private. If the model is private, or if you host a model that is private, that is limited to you. Nobody can see that particular model, and only you should be able to see that model. When it goes public, some of the model that are out there in market and which are public do not require a API key. And when I say API key, like Hugging Face should know who is accessing the model, right? Uh, what request is coming, from where the request is coming. You can make that. Sometimes the model are public. Hugging Face don't even need to know. You just download the model and start using it, right? So you can store your model public. Whenever someone wants to use it, they will download this model and use it, right? What many people also do is they will download the model, fine tune it, and put it back on Hugging Face. Right, there are many models like this out there, right? So to access this, when I say API key for Hugging Face, they call it as access token. You can create in your account whenever you are trying to access Hugging Face model. You might want to put that access token so that the Hugging Face knows who is downloading the model, and you should be able to access and all that part, right? So it is hosted on the these models are hosted on Hugging Face, right? When I call about inferencing and fine tuning, the Hugging Face allows you to do that inferencing thing very quickly. So you just need to pass that model, whichever model that you want to use, download the model and start inferencing with that model, right? So inferencing is what? Would anybody want to discuss that? What is inferencing?
Inferencing is the pre-trade,
Hmm.
trading a model on the data, the data set which we have.
Hmm.
Okay, and fine tuning is basically trading a model on a specific kind of a data. Like if I am using for a text to text
Correct.
classifications, then
Yes.
I have to train my data on text, not on
Yes.
video
And
or.
yes. Anybody else? What is inferencing?
Yeah, inferencing is like using our model, existing model, pretend model. I mean, like to get the output.
Hmm.
That's all.
Yes, inferencing is using the model. It is on the consumption part, ki,
Yeah.
how you want to use that model, right? And fine tuning comes on the updating the parameters. In the on the use part, you are not updating anything. You are not updating. Here you are updating, right? So model are hosted on Hugging Face. You can inference them. You will inference is like you can just download those weights and everything, and use those model directly for your use case. You do not to worry about rest of the thing. So that's what inferencing is. Pipeline is something that Hugging Face has provided, where it is taking care of majority of the things for you. For pipeline, there are certain pipelines available. You just need to put in the name of pipeline that you want to use, like text classification or generation, text generation, or audio classification, or image. So these are pipelines, some of the pipeline that are available already. So for these kind of pipeline, You need not to do anything. You will see just now how simple it is to use Hugging Face. It is just the way we see the embedding. It is even simpler than that, right? It is just 2-3 lines of code and everything will be configured for you, right? Trainer. So Hugging Face also provides something called as trainer, which will give you the pre-trained model. You can train those model on the configurations that you want to. You can have your own data set to train that model, and you can train that model and upload it back on the Hugging Face hub, right? So this is also one service that Hugging Face provide you, and all the pre-trained model are also available. These pre-trained model need not to be specific to something, right? This can be your machine learning model. This can be your large language model. This can be your image model. This can be your audio model. This can be your sentiment analysis model. Or this can be your different kind of model that are available, right? They are all pre-trained, right? You can use those model for your use case. You can use it for inferencing, or you can use it for fine tuning as well, right? Depending upon your use case. So this is the basic, I would say, theoretical understanding of the Hugging Face. But let's just jump into the other part, which is inferencing or using the Hugging Face, how you can use the Hugging Face. Let me just open the notebook for you. I'm just pulling up the notebook. Sometimes downloading the model, depending upon the size of the model, it can take time. That's why I have already downloaded the models, and they're available. We will see how the model works. But for all the coding part or the inferencing part or the discussion that we are having, I would really suggest everyone go hands-on on these notebooks. Because till the time you get your hand dirty, you will not able to understand. Theoretical understanding is something that you can have, but till the time you have like hands-on, till the time you implement that part, till the time you do not debug your code yourself first, till then you will be having lesser understanding compared to someone who has actually worked actually hands-on on that. Yeah, so maybe put it in the chat how many of you are going to do or how many of you are going to play with these notebooks, right? So yeah, Shashwat, sure. I'll share those notebooks, don't worry. You will be getting all these resources. I'll share these notebooks. And not just these notebooks, you need to maybe uh, just some randomly you need to play around with. Let's say if you want to do some transformer, I can implement one or two type of pipeline. Maybe you want to explore different type of pipeline, how it is working, right? You want to read some open source, how they are implemented. Hugging Face already provided many guides of how you can use those models, right? So just explore around that. Just get handy with debugging your code. Just get handy with learning new things, right? Getting started with this. If you are open to debug, get into, understand, and everything, this will be like a cakewalk for you, right? So to start with, we need to install this transformer package that is available. You just do pip install transformers, and I believe all of us are handy with Python, so all these terminologies will make sense to all of us, right? So that's my understanding is. If someone is not, maybe they can put it in the chat, or else I'll proceed further, right? So I'll just do a pip install my transformers library, and then I will just import the pipeline from my transformers, right? This pipeline is doing a lot of things internally. What it is doing, we will see, but this is like a wrapper around those Hugging Face transformers on how you can use them. And when I say wrapper, it's like there are 10 lines of code that you need to write for a particular things to get done, right? So these 10 lines are already written for you, and you just need to import that pipeline, and you need to just give the name of which pipeline you want. Let's say in this particular scenario, I'm doing a text generation pipeline that I'm putting, and this is the name that is already Hugging Face has already provided, I think, 15-20 pipelines. You can use any of these pipelines to get started with, right? So for this scenario, I'm doing a text generation. This is not a random word that I have put in. This is the name of the pipeline that should be available, right? And you just configure this pipeline, and I'm just putting in a random seed. Some of you might be aware of, who are not aware of this terminology called setting up seed. Maybe not, I would say Google it, or like this is your homework. You can read around this. Okay. So I have created this generator object of my pipeline. This is my transformer pipeline, which is set for text generation. And by default, there is a model that will work underneath. That is the OpenAI community GPT model, GPT-2 model that is working around like under the hood. This is the default model. If you do not pass the model name, it will go with the default model, or you can pass the model name also, right? Maybe I would want you to explore different models and try how this is working, how good or how bad if you are able to get working with different models, right? So these models are again hosted on Hugging Face Hub. You just need to pass on these models. So this model is also hosted here. See, huggingface.com, OpenAI community GPT-2 model. This is the default model for text generation. Different pipeline can have different models depending upon the use case as well. Okay. So I'm just passing this my statement for which I want the model to generate those text, and I'm putting in the maximum length of 20, right? So it's like the maximum length of each sentence that it is going to produce would be 20, and I'm passing it how many sentences it can produce, right? So on transformers, the purpose is to generate the GPT models or the chat GPT models. They are at next level to this. This is transformer. Transformer is further evolved to the GPT models. How many of you know that full form of GPT? Put it in the chat. No Google, no searching, just put it in the chat. Or if you don't know, that's okay. Even I didn't knew till like very recently, though I was using it. But it's okay even if you don't know. So maybe if you know, maybe put it the full form in the chat. If you know, if you don't know, maybe put a no in the chat. Oh my God, everybody knows. I was the only one who didn't knew till recently. Okay, we have smart people in the session in the group. That's good. Um, so it's just that I'm configuring. So this is like how I'm configuring my pipeline to work, right? So I'm passing the generator object some of the input that it needs to work on. I'm passing the maximum length and the number of sequence it needs to return, right? And just by running this notebook, see, I'll be able to get this. These are the 5 sequences that are generated that I have set already, and each sentence would have something different. Sometimes it might be very good, sometimes it might not be very good, right? So this is how simple it is to use a transformer pipeline. In embedding, we had
Wait,
3, 4, but
hi.
here it is just 2 lines. Yeah.
Just a question. On what basis it has generated the 5 sentences? It is random or how is
This
it?
is the text
Uh,
that we have provided. Hello, I am a language model. Based on
okay.
this input, so this was the input going on. It processed it input and predicted the next token. Then again predicted the next token. Then took this in the input and predicted the next token. I am limiting it to the sequence of 20. So I'm limiting this so that it goes till a 20, and at 20 it will do a hard cut. Hard cut is like I'll just break, I'll stop the network. Okay, don't produce more. That's it. And I'm doing this 5 times. So I'm producing 5 different sentences. Here are all those 5 different sentences. And this is a text generation model. So it's like it is predicting just the next word. The transformer underlying the GPT-2 model that is underlying, it is just predicting the next token. And it is showing us that output, right? Similarly, we have text classification. So
Here,
this is mhm,
here next token is a sentence or
word.
you are referring to what word?
No, even sometime it can be lesser than a word. We will see in the notebook further. It will be there. A token is not a word always, but many a time the token you can in a broader term for broader understanding you can say a token is a word, but token is not equal to word technically. We have discussed that in our earlier sessions. So maybe you want to revise that, but we will see that in practical. We will see that today, right? Similarly, we have a pipeline called text classification pipeline. Out of those 15 to 20 pipelines that are available from Hugging Face, this is another pipeline for text classification, which classify whether the input statement was available in particular, let's say positive or negative or not. So this text classification pipeline is doing that. I'm putting in the statement called I'm enjoying learning about transformers from Hugging Face, right? So what do you think the sentiment of this particular statement is? Is it positive? Is it negative? Maybe speak up or put in the chat. Quickly, we do not have much time. Yeah, Saswat says positive. Great. So if we see in the output, so it is as simple as we are running this. We are building this pipeline first. We are doing classifier is equals to pipeline, and we are defining the name of that pipeline, which pipeline we want to use. And then we are doing classifier, and we are giving the input statement. For this particular, just by giving the statement is okay, because there are some default parameters already set inside that for text classification, we are dividing it into positive or negative, right? So it gave me the probabilities. It predicted that it was positive, and the score, the confidence of this, the probability of this positive was 0.9999, right? Because it had terminologies like enjoying and all that. But let's wait. If you want to classify not just the positive or negative, I want to classify it in, let's say, some heads that I can custom define, right? So let's say I am using for that zero shot classification. This is the, again, name of pipeline. I'm just changing the name of pipeline. If you see, I have imported pipeline once only. Here I have imported the pipeline. I'm just changing the name of pipeline that I'm using, and I'm changing the input parameters. Here, this is my statement, and then there are some candidate label on which I want to classify this statement on, right? Underneath, it is using this model called BART Large Minil, MNLI. This is the model name from Facebook, right? This is the default model. You can go ahead and change the model and see the changes in the output. But we are giving those candidate labels. So the task is it will be classifying this input statement in among these three labels. What is the confidence for each level? So if we see, this was the input sequence that I have given. This is the same. This is all about learning transformers from Hugging Face. And for education, it gave me, it was confident by the probability that was predicted, it was 0.92, which is highest among the other probabilities, which is 0.6, 0.06 for drama and 0.0008 for politics, right? So this is how you can use those pipeline. Underneath, there are a couple of lines of code that is going, then I have mentioned it here. This is the code underline. This much line of code is already available for you just by changing the name of the model, name of the pipeline that you are working with, right? So you are defining a model. For this scenario, let's say this was the model that was available, right? Distilbert, uncased, fine-tune, SST, English. This was the text generation model, the default one. And how I use this, I tokenize first. First of all, when I'm putting in the input, I'm tokenizing each of my input statement, or whatever the input statement will go. I'm preparing my tokenizer object for that, right? Whenever I'm taking an input, I'll tokenize this input and then pass it to my transformer model further. So this is my transformer. This is auto tokenizer that is available from Hugging Face already. Which makes it easier for you to tokenize that model. Remember, we were using the tokenization. This is doing that tokenization for you, right? You just put in your text, and the return tension is like either you want to return that as a single list, which you would be difficult to classify. But if you want to return this as a tensors, it will be easier for model to grab it, right? So we are returning the tensor from here, and for this, we don't want to change the weights of the model, right? We don't want to change the gradient descent. So this no grade is like we don't want to update the weight of the model. We are just inferencing, and we are passing this input to the model. And model is actually not predicting the tokens, right? It is predicting the probability of certain token, right? And the token itself is encoded again based on the index number of that particular token, right? So it is predicting all those logits. I can extract, this is where actually the prediction of those tokens is happening in this particular line. And this is where I'm extracting all those probabilities from the model predictions. Now this logits have my all these probability. Now this is my softmax function. This was my activation layer. Remember, this softmax was our activation layer in our neural network. I'm applying the
Yeah.
softmax function here so that I can actually distribute those probabilities. Whichever has the highest probability can take the higher output in higher stake or higher weight in my output, which has a lower will go on the lower side, right? And this is the output that I'm getting. Predicted class is 1. 1 means positive. And this is the tensor information. This is the probability that I have. So for this is for 0. 0 के लिए it is 0.00, like 4 decimal place के बाद we have 7. And for 1 it is 0.999, right? So this is how internally the pipeline is working. It is available for you just simply giving the name of the pipeline, but this is how the internal of the pipelines are working. They have made it easier for to start with, to play around with. But all the transformer model that you are going to work with, we need to have this kind of architecture for whatever input goes inside the model. This is called pre-processing in terms of transformer or the neural network, that you are processing your information before you are feeding it. And this processing is like tokenization of that information that is coming in. And then you are loading your model, auto model sequence classification model that you are loading in. And what model you want to load, that is already available. But these models would be available on Hugging Face app directly. You can use the model. And we also need to make sure that for what task, what model we are using. The model should be compatible with the task that we are trying to work with, right? Is it okay if we can exceed for 5 minutes, because we'll be closing this and we'll take up next from tomorrow? It's okay if we exceed by 5 minutes? We'll close it by 9:10.
Sure.
Yeah, everyone?
Sure.
Okay. Okay, thank you. We'll finish it as soon as possible. So when I said that we need to tokenize, so see, these are all the tokens that are available. So the input statement that I had was, it's good to learn working of transformer with Hugging Face. And it is broken down into these many tokens. If you see, it is broken into 3 tokens. And then this Hugging Face is broken into 2 tokens. See, so not always one word is a token. One word can be broken into 2 tokens, and it is not just also about character. See, transformer is a bigger word. Itself it is a token, but Hugging Face, despite being of like similar length in terms of character, it is broken down into 2. So it depends upon completely upon the model that we are going to use, right? How good it is at understanding, or what is the lookup table that we had for that particular scenario. It depends on that. For transformer models, this tokenization, breaking down the model, processing the input information when we are putting inside the transformer, this is to be done. But for GPT models, we need not to do this. We just give the text. Internally, it is taking care of everything, and you're just consuming all that information, right? Similarly, if we see the internal working of the pipeline for the text generation model, we are doing the similar stuff here. We are tokenizing the information, we are loading the model. This pre-trained is something we are already, like, we are loading some pre-trained model that is available on the Hugging Face app. This pre-trained is going to be the key thing in here, that we are loading the pre-trained model that is available. This is an important method. Okay. And then we are passing in our prompt. So this is for our text generation. That once upon a time, I'm just giving this input and asking the model to generate some story. But I don't want it to produce till any length. I'm putting a maximum length of 50 tokens. I want it to make a story which is of 50 tokens in length. At 50 tokens, even if the story is incomplete, I'm trying to, like, I'll do a hard cut. This is till where I want it. There are other configurations as well, which I would want you guys to explore with, but this is the basic to get started with, right? And then you predict the output IDs, right? And then once you have the output IDs, you decode those IDs, because now it is not about just the classification 0 or 1 that we were doing earlier. Now we have those tokens, right? So when we are converting into embedding, we are breaking into tokens. For each token, we have something in the lookup which will take the index, and this index will represent some vector, and that vector will be used further, right? Now it is predicting that index, right? And I need to convert that index back into my original word, right? So this is where it is happening, that I need to decode whatever my transformer has predicted. This is not there in my GPT models because this is already internally taken care of. So for transformer, we need this decoder encoder kind of architecture. For GPT models, there is no such transformers like this encoder decoder kind of thing. So this is a generated text. I gave in the input once upon a time, and it is trying to make this story. The world was a place where great beauty, great danger. The world is a place with great danger. So see, it is trying to uh, create a story. Again, the story can be good. The story can be pathetic, depending upon the model that we are using. The model, particularly the model that we are using, but it is trying to predict that. And if I see what was the length of the tokens that were generated, it is absolutely 50 because I have done a hard cut in this particular scenario, right? So this is how we can use those Hugging Face models and transformer models basically to get started with. Definitely there is a lot more additional to this, which I would want you guys to explore. If you face any difficulty, try to resolve, search over internet, read some blogs, read some use cases, how you can use it. Maybe explore. But that's what I would say. Explore, get your hands dirty and start learning this, right? Um, this is where I'll stop for today. We'll start with fine tuning and rest of the thing from tomorrow. If you have any questions, we can discuss it now. It might be overwhelming for some of us, but don't worry. I have tried to put it in the simplest possible way I can. Um, Maybe go through the lecture again and explore over the internet.
Hi, Amit. I have a question. This Hugging Face transformer is only transformer model or package available, or there are some other package related to this transformer also available?
No, so for
Like
Hugging
from
Face, yeah, if you want to use Hugging Face transformers, everything is available in this transformer package. If something additional comes up, you need to have that package. But for transformer, using those transformers and everything, there are some additional that auto tokenizer that will help you tokenize the information. Then to load the model, then you will have something called auto model for class casual LM. For classifier, you had something called auto model for sequence classification. So these are some supportive packages that are there that you can use. And for different use cases, you will have different kind of such methods or classes available. You need to use it depending upon the use case again.
So Ankit
okay,
here,
so
mm, you have like passed only like one text at a time, right? Like if you have like if you want to pass some like multiple, like rows or like multiple, if you want to find the this what do you say this positive or negative for multiple reviews, let's say, if you want to pass it as a file, we
Hmm.
can do that as is, or we can directly do it, or we should like go through each and every row in that file and call this inference part
No,
for.
that depend upon your use case. If you want to have, let's say, for the whole document, I want to go statement by statement, get the probability score for each statement, then average out for my overall document. That is one. Second can be you pass the complete document at once and then say what was the output, right? Whether it was positive,
Okay, yeah.
negative. So depending upon the use case, it will be applicable. It is not like one size fit all kind of scenario.
Okay, okay, got it. Yeah, thank you.
Yep. Yep. Someone else was also saying something. If you don't have any doubts, guys, we won't be discussing any more concept today. You can drop off. I don't want to take much of your time. If you have any doubts,
Amit,
we can take it
actually,
now.
I have another question. So
Okay.
this transformer package is from Hugging Face, right?
Yeah.
Uh, so, are there any other transformer package available from another group or companies, or this is the
Uh,
only transformer package available?
I think for all of your scenario, this transformer package should be enough. And I don't think there is more available, but again, you can surf the internet. I'm not sure, but I don't think there is more available. That's the all the
So
for all the
generally,
transformer, this will be working.
Hugging
Hmm.
Face transformer is
Yes.
used. Okay,
Yes.
thank you.
Yep. Do we have more questions?
No, not from my side.
Okay. Thanks. Thanks, Ashwath.
Thank you. Thank you.
Yeah. I think we
Bye.
can
See you.
call it a day. Yeah.
Yeah, see you tomorrow. Bye.
Okay. Thanks. Thank you. Bye bye. See you tomorrow.